Hello everybody, this is Satya Malik, and in this video, I'm going to show you how to use DepthAI. We'll take a baby step, a very small step, to understand how DepthAI, which is the API for programming OpenCV AI Kit, can be used. And all we are going to do in this demo is we are going to use the DepthAI API to access the left and the right cameras of OpenCV AI Kit with Depth OAK-D. The same code will also work with OAK-D Lite. So we will use the API to create a pipeline so that we can see the left and the right camera views. So it's a really small baby step, but it's very important to understand what this API, how this API is organized, and what does a pipeline mean, what do nodes mean, etc. So here in this video, we are going to cover the DepthAI pipeline. What is a pipeline? What is a node? And then we will use these two concepts to access the left camera and the right camera. And then we will just display them. And when you see them displayed side by side, there are two different ways we are going to display them. You will see how disparity, which means that the change in viewpoint, leads to the same point being displayed at two different locations in the two different camera frames, and how that information can be used to create a depth map. I'll talk briefly about it. In the next video, we will go into depth of how stereo vision works. So let's get started. What is a DepthAI pipeline? So to explain this, it's basically a collection of nodes. The pipeline is a collection of nodes, and a node is a unit with some inputs and some outputs. And the pipeline is basically a collection of these nodes that you tie together. The output of one node goes into the input of the next node, and so on. And it is best explained by way of an example. Let's start this. Now, you can install DepthAI using instructions I have shared in a previous video. In this video, I'm assuming that you have installed the Python version of DepthAI. And so you can simply start with import DepthAI as DAI, as shown in the screen. And you start a pipeline by simply saying pipeline equals DAI.pipeline. So now we have this pipeline object. If you look at the screen, we are actually dividing the screen into two parts. On the left is the device or OAK-D. So we are trying to say what's going on inside the device when we write this code on the host. The host is basically a computer or a Raspberry Pi, which is connected to your device or OAK-D Lite using a USB-C connection. That's the only way it works. The only port here is a USB-C connection, which also supplies the power to these devices. So we start with this. We have created a pipeline. So nothing has happened on the device yet. So let's move on. So we do mono equals pipeline dot create mono camera. A mono camera is one of these two cameras. So we have the right mono camera and we have the left mono camera, and we have a center RGB camera. In this demo, we are just going to deal with the left and the right mono cameras. In particular, let's start with just the left camera. So we have created a node for the mono camera, and you can see that inside this OAK-D, we have now just established, we have just recognized that there is a mono camera. We have not connected it to anything. We have just created a node. So next we go and create, we mentioned that this node that we have created, it is the left camera. And the way to do it is to say mono.setBoardSocket, and then we specify that it is the left camera using that expression. Now, internally what it does, it creates something called an X-Link in node. So this node is created internally, and X-Link is basically a mechanism using which the device, your camera, connects to your computer. So whenever you hear this word X-Link, it is basically a connection between your device and your host or your computer. And you can have X-Link in, which means that it is an input to the device, or X-Link out, which is an output from the device. And in this video, whenever I mention the word device, it actually means your OAK-D camera or OAK-D Lite camera. And whenever I mention host, it is your computer. So when you run these commands, you will see that this link is created. I mean, you will actually not see it, but internally an X-Link is created and it is attached to the left camera. Now, so this input is specified now, and we already have a little pipeline going here, but nothing really is happening. You know, you cannot see anything unless you actually get the output out. Let's see how the output works. So next we create an X-Link out using pipeline.create X-Link out. And then we name this output because there could be several outputs. There could be one output for the left camera. There could be one output for the right camera, for an RGB camera. There could be other outputs also which are part of a neural network output. But let's worry about it later. We have to specify the name of the output stream so that we can use that name to later get the output out. Okay, so that's what this piece of code does. Then we have still not linked this mono camera to the output. And using this, as you can see here on the screen, mono.out.link, we are taking the output of the mono camera and putting it as the input to the X-Link out, as you can see here. And now we have established a connection. Okay, so next what we are going to do is this pipeline. I actually cheated a little bit. When you were writing this pipeline, all the instructions were being actually run on the host. Even though I was showing that, oh, these things are being built on the device, they were actually not built on the device. They were on the host. But with this line of code, with DAI.device pipeline as device, with that line of code, we have actually transferred this pipeline onto the device. And now we are ready to query it and do whatever we want to do. So with that, you know, I've just indicated using this green box. So next, we are going to actually query this X-Link out to get our frame. Now, one thing to keep in mind is that the output of X-Link out is not a single frame in this case. It actually creates a queue. And in this queue, you can store many frames. So for certain applications like video encoding, you may need to store many frames for doing the processing. And that is why you have this option to have a queue. And we don't need, in this application, our queue size could be simply 1. But I have just set it as default for now. So the output is essentially a queue. And from that queue, as you can see here, we say that queue equals device.getOutput queue. And we have to specify which output are we talking about. So we are talking about the left output, which we had specified earlier in this line of code. So once we have the queue for this X-Link out, we can query it to get one frame. And we are just saying queue.get to get that one frame. And from now, the frame actually transfers from the device out into our host. Once we have that, all we need to do is use frame.getCVFrame, and getCVFrame actually converts the frame that we have received into OpenCV format. Because OpenCV is the most used computer vision library in the world, we just have provided a nice function that will allow you to convert your frame into OpenCV format. Now you can use OpenCV functions like IMShow to display this frame. So that is it. So here just to summarize what we have done, we just imported the library first, and then we created a pipeline. Onto the pipeline, we attached the left camera node, and then we attached an X-link out to get the information out from the left camera. And we just need to specify a few things when we are doing this. We need to specify the name of the output stream, and then we have to keep in mind that this output stream is actually a queue of outputs, and so we have to query the last one. We have to do .get to get the last output, and then we can use get CV frame to convert it to an OpenCV frame and then display it. That is it. So this is what you can easily do. But let's go beyond this, right? Let's create a slightly more complicated pipeline, and our pipeline would look like this. We have the left camera, we have the right camera, and we also have two X-link outs, one for the left camera and one for the right camera. And this will actually give us the frames from the two cameras, and we can display the frames and see how it goes. Now let me show you the code and show you how simple it is to get this going. But before we do that, let me show you the output, the final output of the code that I'm going to explain. As you can see, that the output of this is essentially the left frame and the right frame. They are not the same. They may look same to you if you're looking at them side by side, but these frames are not the same. They are from the left view and the right view, and you can toggle it using the letter T, and they merge onto the same frame. And now you can see that there are two different frames. And yeah, this is what we will show. And this code is actually running on this device, as you can see. This is OpenCV AI Kit with depth. All right, so let's go over the code. So first, let's go over the main function. We have a pipeline. We first define the pipeline as we had seen before. We have this utility function where we say get mono camera, and we pass in the pipeline as well as the option to get the left camera or the right camera. Let's quickly go and see what's happening inside a get mono camera. If you go inside mono camera, it creates the mono camera like we have seen before. It does one extra step. We are setting the resolution of the mono camera to be 400 pixels across. And there are a few different options there. You could use 720, you could use 800, you could use 400 to set the resolution of the camera. We have set it to 400 here. And then based on whether we want the left camera or the right camera, we use mono.set baud socket, and then pass in this to get the left camera or the right camera. Very simple code. So yeah, so we get the left camera, we get the right camera. And now, as I had mentioned before, we have to actually set the output X-link out. So this one is the X-link out for the left camera, and we have named it left. Similarly, we have X-link out for the right camera, and we have set it to right. And then we need to attach the left camera to X-link out left and the right camera to X-link out right. And that is what is being done in these two lines of code. So now we are ready to load this pipeline. We have defined the pipeline. We want to load this pipeline onto the device, onto the OAK-D or OAK-D Lite. And this is done with this line of code. And once we have done that, we have to actually define the queue. So left queue equals, we try to access the left queue and the right queue. And these names were defined earlier right here, as you know. In addition, we are also specifying that, we don't worry about, we are only worried about the last frame. So the queue size, we are going to say it is going to be 1. So this max size here is the size of the queue, how many frames it is storing, how many history frames it is storing. And we don't care about more than 1, so we have set it to 1. Here we have a named window, which we are just calling stereo pair. And people who are familiar with OpenCV will immediately recognize that this is the function you use to create an OpenCV window where you can display images and plots, etc. This is a variable where we have the option of going side by side or merging the two frames together. We have also, now we are looping inside to get frame again and again. Once we have established, we have transferred the pipeline onto the device, and everything is ready. Now we just have to loop over and over again to get the next frame. And that is what is happening in this loop. And once we get the frame, we have a utility that we have written. We have written a function to get frame. And all it does, if you go and check it out here, all it does is it gets the last frame from the queue and then converts it to OpenCV format. That's it. And okay, so we get the left frame, we get the right frame, and based on whether we want the side-by-side view or we want the merged view, we are basically stacking side-by-side, and np.hstack helps us do that. For people who are familiar with NumPy, this will be very familiar code. For people who are not familiar with NumPy, this is just hstack stands for horizontal stacking. So you can use hstack to stack two frames of a video, two images. If you're not stacking them side by side, we are actually averaging them and putting them together. So half of this frame and half of that frame, we are just adding them together. And this is what this line of code does. And finally, we are simply displaying the results. And when if you hit Q, it quits. And if you hit T, then it toggles between the two views. So let's run the code and see a little bit more about what's going on. So the first thing to note is that the left frame, the thing that I'm calling the left frame, is on the right-hand side. It is the left of the camera, but it is actually on the right-hand side. And we can easily see this by, so this is my right hand, and I'm going to block the camera. So you can see that by blocking the right-hand side camera, I'm actually blocking the left camera, whatever I'm calling the left camera. So, I mean, it's not, you're not going to be confused by this, but it's something to keep in mind just in case in future. Usually you work with the depth map, you don't worry about which camera is which, but still, and you can do the opposite experiment here. I'm blocking the left hand side. This is my left hand. I'm blocking the left hand side camera, and you can see that the right view is affected. So not only that, let's toggle the view and see some more things, right? Now, for people who are not familiar with stereo vision, this is a very good demo. If you look at my face, it is very close to the camera, and in the two views, there is a difference where the face is located, right? And that difference is called disparity. So where a particular point lands in the two views, it's called disparity in pixels. So disparity is usually measured in pixels. So you can see that my face pixels have a large disparity. But if you look at my background, the door, the corners of the door, you will see that they are pretty much aligned. So it gives you a sense of how stereo vision works. The things that are close by, they are separated, and the things that are far away, that are not as much separated. So by looking at this information, we can say which things are closer and which things are farther away. That gives you an intuition how stereo vision works. So that's all I wanted to cover in this video. In the next video, we are going to see how to actually get the depth map out of OpenCV AI Kit with depth. And we will learn a little bit more about how stereo vision works, how matching works, what is image rectification, etc. in the next video. So even if you do not own OpenCV AI Kit with Depth, OAK-D or OAK-D Lite, this will be educational for you, just to look at these images that are coming out of these stereo cameras. So that's all. And if you do not have an OAK-D or OAK-D Lite, we have given the link from where you can purchase one of these devices. These have been very popular in our Kickstarter campaigns. People love them. So if you want to try your hands with an AI camera, which can also do depth in real time, these are excellent options. And these are very educational. So give them a try. And we'll see you in the next video. I'm building this, this set of tutorials one after the other. And I'm trying to get to a point where it's not just about explaining the API. I want to give some intuition about how things work, how stereo vision works, how neural networks work, etc. And not just tell you about the API, look, use this command. No, that's not what I want to do. I want to explain some intuition behind how things work inside the camera. That's all for this video. Thank you so much.